All right, good night once again. So tonight we're covering database. Remember, as before, the session will go a bit fast. We're trying to cover as much content as possible. If you're not clear in anything, ask me at any point in time to repeat, to go over back whatever you need to clarify. If you have any questions, ask at any point in time. All right, so let's get started. So we're looking at database. Point to note, at the end of each chapter, most chapters, there's a practical exercise. I won't be going through them, but it's beneficial on your part if you do go through them. For spreadsheet, database, Word, web page, there's practical activities at the end of some of those chapters. Go through them. The IT exam poses the question in a practical manner. They may ask you how to do something, and then you have to describe how to carry out that action, how to add a page number, how to create a query. So unless you're practicing, that might be the only way for you to remember how to do something, how to say what is being done. Either way, so database, introduction to database management. The two types of databases that we have is manual and computerized. A manual database is basically anything that doesn't relate to a computer. But firstly, we should ask ourselves, what is a database? So a database is basically an organized collection. Notice this key word here, organized collection of structured information or data, typically stored electronically. Ignore this last part here. So a database is basically an organized collection of data or information. So you could have a collection of data, you could have a collection of information, but if it's not organized, technically you don't really have a database. So a database, one of its characteristics is that its data is organized. So examples of manual databases are like a filing cabinet. Anything that's physical, anything that doesn't deal with computers, that is what we considered manual. So the bookshelf that you might have at home, the library, a phone book, anything that has data organized, we call that a manual database. And a computerized database, that's basically any form of collection of data that is organized on any form of computer, called a database, a computerized or electronic database. So the list of music that you have on your device, the list of books that you might have on your device, the list of photos that you have on your device, those are computerized databases. Those are simple examples, all the way up to larger databases, those stored by hospitals, universities, and so on. So those are the two types. So nowadays, computerized databases are in widespread use as they help people quickly find the information that they want. They also vary in size and use depending on what is required. Small databases, such as those that keep information about a music collection, can run on a personal computer at home. Larger databases now play an important role in how our society works. Industrial, commercial, and public organizations use databases to maintain their business and services. So a lot of businesses, organizations, they cannot live without a database. For example, Amazon. Amazon uses a database to store all of their items. If that database was to suddenly go out of existence, then as you browse through the Amazon application, you will not be able to find any items. A hospital stores all of its updated hospitals, first-class hospitals, we should say. They will be storing their data on computerized database. If that database was to get destroyed in some form of way, then a lot of patients will be suffering because you won't get their records. Even the manual database for hospital, if that was to suddenly go up in flames, then a lot of patients would be in a lot of trouble. So databases for all organizations and businesses are very important. Other computerized databases include flight information system databases in public libraries. So even all of the flights, the arrangements, and so on, the bookings, all of that is being stored in databases. Examples of how we use these large databases: storing information on booking holidays, airline tickets, using an online store to search a range of millions of products for a particular item, accessing a police computer database with requests from police officers who want information about criminal suspects or stolen items. Even the police has a database about all the criminal records, all the acts they would have done, and so on. Although spreadsheet databases have similar features, there are three main differences. Databases are more often used for applications with large amount of text. So that's the main purpose of database, to store text. Whereas spreadsheet can handle complex numerical calculation. So database, text, spreadsheet, numbers. Very large applications with thousands of entries are more often handled in database. So if you're storing large amounts of data, it is more preferred to store it into a database rather than a spreadsheet. The way they work in the background is different. When you work in a spreadsheet, you view the data you're entering. So as you work in spreadsheet, you can see the data in the database. You only see the data you are entering at that point in time. If you want to see any other data, you either need to request it with using a report or using some sort of different display to see the information. So we use a report query to basically ask the database for us to view a particular information or data. What is a DBMS? A database management system. This is a term for any program that handles the storage, modification, and retrieval of data, as well as controlling who has access to the information. So, example of these, we have Microsoft Access, which you guys would have learned about, Lotus Approach, FileMaker Pro, Coral Paradox. Those are all examples of DBMS. They allow you to create databases, modify it, store, retrieve the data, and so on. Advantages of computerized database over manual database. So you can save large amounts of paper. You're basically taking up less space. Think of all the filing cabinets that you're going to be replacing. You can easily enter data by using a keyboard, typing the data, or scanning the data. It's much faster to enter the data with a computerized database. You can even perform calculations faster. You can easily change the data and update it. So you can easily go into the database, type the correct value, type in your input, and it's changed right away. Data needs to be entered only once, and yet it can be presented in many different ways. Think about a paper system. If it's already printed one way, that's it. You cannot change it unless you go and print it another way. Whereas a computerized database, you can take this one data and present it in different manner, in different forms of queries, in different forms of reports. Data can be checked on entry. As you type in, you can check as you're typing. You can set a password so that only those who have the password can access the database. The structure of the database can be changed. So the database, think of it as a table. When you have a table on a paper, in order for you to change that table, if there's space on the paper, yes, you can maybe manually put in another column. But if there's not more space, you got to go and manually add that in or recreate the entire paper with that database. With a computerized database, it's much easier to rearrange the entire table, add in new columns, new rows, and so on. You can import data. So if the data already exists in some other database, it's easy for you to import and even export. Send the data to another database or to someone else. A database file can be automatically linked to other databases. So you can connect databases together to make an even larger database. Databases can be shared with other users if the computer is part of a network. So you can easily share and connect. Now, what are the disadvantages of a computerized database? Buying computers, setting up all infrastructure is going to be expensive. If the computer goes down, if the network goes down, the database basically goes down also. Security is an issue. Somebody can hack into the system and try to steal the data or destroy the data. The database file or the system could be corrupted by a virus, so you can lose some of the data. This is why backing up the data is very important. The database is limited by the file size. Certain programs has a maximum file size as to what you can create. That's going to limit the database. Some databases are complicated. You got to train the person as to how to use it. So this goes into the next one. You got to spend time training the staff, which can be costly to the company. And humans make mistakes. As you type in, data could be stored incorrectly. So those are the advantages and disadvantages there of a computerized database. For those that just joined, remember, if you have any questions, clarification, you're free to ask at any point in time. Common database features. So this is basically the structure of a database. So the yellow part is indicating the database, or say the database file. So the same access file that you would have created, imagine that as the yellow box. So the main purpose of a database is to store data. It can store this data in a number of related fields. Related files are more commonly called tables. So in a database, data is stored in tables. So you make your database and then you create tables after that. That is where your data is stored. Now, in your tables, your data is going to be stored into fields. A field is the smallest piece of data. Think of it like spreadsheet. How a spreadsheet has a cell basically in database, we call that a field. One piece of data goes into that field. Now, when you combine a group of fields in a row, we get what is called a record. So a field is the smallest piece of data. You group fields in a row, you're going to get a record. And when you group all of those records together, you get a table. And when you group all of those tables together, you get a database. That is the structure basically of a database. All right, so this is just an example as to how a database might work. Now, whenever you're creating a database, tables, why we have different tables, why we don't store everything to one table, because one table should have a particular topic, one specific topic. Like for instance, this table at the bottom here, it has information only about the customers. This table on the right-hand side here has information only about the items. And this one at the top has the information only about the orders that the customer would have made. Now, by connecting the table together, we can indicate the relationship between the tables, how information is connected to each other. So this is straightforward. The ID of the customer, 1138, is placed in this table at the top here, and it's connected to the ID of the item, P3745, and that simply indicates which customer would have bought which item, and then we have an additional information as to how much item that customer would have bought. So it's that straightforward. You just gotta match the fields to read the database. So some terms in database, we have object. What is an object? An object basically refers to what makes up the database, what you can create in the database. So that includes the tables, the forms, the queries, the reports, the macros, the modules. All of those can be created in a database. We call them objects. What is a database? Basically a collection of tables. What is a table? A table is a collection of records about a specific topic. What is a query? A query is when you're asking the database a question. What is a form? A form is a graphical user interface or a graphical representation of a table. You use it to enter data or to also view data, to enter data, display data, search for data. But remember, your table is the main storage. The form is simply connected to the table. So the form will show what is inside of the table. So if you add something into the form, it's technically being stored into the table. And then it's also going to show that in the form. What is a report? A report is when you want to summarize the data of the table, when you want to summarize or format the data of your database. So present that data basically so that persons can view basically a report. What are the rules? What are the guidelines when we're creating a table? Before you create a database and its tables, you must first choose an appropriate name for the database that describes its purpose. Then provide suitable names for the tables based on the type of records that they will be stored. So that's the general gist of when you're naming anything. The name should describe what it is. So let me jump to this part here. So the rules for field names. So the name must be meaningful, and the name should not have any space. Those are the two rules that you should remember. The name must be meaningful. It must not have any space. Instead of a space, you can add a dash, you can add an underscore. So like this case here, or you can add no space at all and make each word initial cap, which is basically the first letter, it's capitalized. So those are the two rules when you're naming field names. Now field names have data types. So a field is basically where you're storing the data, but you have to say what type of data is now going to be stored into that field. These are the common field types. So we have short text and we have long text. Now short text has a maximum of 255 characters, whereas long text does not have a limit. Numbers, that's only for numbers. Date and time, that's straightforward. Currency, auto number. Remember that automatically increments 1, 2, 3, and so on. Boolean, anytime you hear the word Boolean, that's referring to two values. When you only want to represent two values. So like yes and no, true or false, on and off, and so on. All object data type, when you want to add a picture, a video, a sound file, and so on. The lookup wizard, you use that when you want to have a drop-down box. So like for instance, instead of typing in male or female, you could have a drop-down box and it's going to give you male and female and you select from that instead of typing it in. Hyperlink, that's straightforward. Gives you a link, like if you want to type in a website, if you want to type in an email, it's going to make it clickable. And then attachment, when you want to attach other files, images, spreadsheet file, other documents, charts, and so on. Those are the various data types. Once again, we use data types to indicate what type of data is going to be stored into the field. Now for those fields, we can set what is called the field length. The field length is simply the maximum number of characters. So like we said, short text already has a maximum of 255, but we can further reduce it to 10 if we so want. Now why do we need to do that? What's the practical reason of doing that? The practical reason of doing that is because, say for example, this 255 character. Say for example, 255 character takes up one character equals 1 byte of data. So 255 character is going to give us 255 bytes of data. Now in database, we try to make the database file as small as possible. Now this is just one field. If we have 100 of this here, so 100 times that, that's 255,000, 25,500. So that's going to be basically that in bytes also. Now, if you'd used the field length and maybe reduced it, so this here might have been 10 character for each one of these fields, and if we do 100 of it, so that now is only going to be 1,000. So that's 1,000 versus 25,000. So that might sound like small, just basically 15,000 bytes. But this is just one example in that if you were to scale this up into a larger database, the file difference could be significant. So what we're trying to say here is that you try to make the database file as small as possible. And when you set the field length to use smaller number of characters, that helps to reduce the file size, basically. So that's why we would use that. But you gotta be careful when using it. Like for example, if you're gonna use it on name, you have to be reasonable. Yes, some persons don't have lengthy name. Like for example, in Guyana, you mightn't find a person's last name greater than 30 characters. But if you go to any one of those, maybe indigenous countries or so on, you will see them greater than 30 and so on. So just take that in mind. Field description, that's simply to give you an idea as to what the field is about, what you're putting into that field. What are the field properties? The field properties of a field is basically a set of options that you have to format the field, you can see. Just like on spreadsheet, you can format a field. The field length is one such of those formatting options. So what are some of the other options you have? So field length and field size are both the same. They allow you to limit the amount of characters. Format, so that's just like in spreadsheet where you format a number as currency, as percentage, and so on. Decimal, that's straightforward. Add how much decimal places you want. The input mask is used to set a pattern as to how the data is going to be entered. Like for example, if you're entering a phone number, maybe you want the pattern to be 592 and the rest of numbers, hyphen, and then whatever else. So you can set up an input mask to say that this is the pattern, type your phone number like this here, instead of the person wondering whether I should type the area code or not. Caption, this is basically an alternative name to the field name, kind of like a nickname. Default value. So in a database, this is important to remember, no field or no record should have an empty field. No field should be empty. We try to always have information in that field. So if there's a case whereby we do not know what should go into this field, we could set up what's called the default value so that something appears by default so that the field is not left empty. So like for instance, if we're typing in the price of an item, we're typing in the person's phone number, we could simply say let 0 appear if we don't know it. So at least something goes in there. What is the validation rule? So field size, that basically sets like the upper limit, the maximum character that you can use. So if you set a field size of 10, you cannot go past 10 characters. Now, what's going to limit the lower side of it? Like for instance, if you want the range to be 5 characters to 10 characters, well, the validation rule is what can actually help you. So the validation rule, you can say that the number should start from greater than 4. So you can set up this rule here and say, look, if the person is entering a number, it should be greater than 4, or it should be greater than 999, so that the person has to go from 1000 to whatever value you set up. So that's the validation rule. The validation text is that if the person violates the validation rule, this message is going to appear. So if the person types in maybe the number 3, then the validation text will appear and say that, look, You cannot enter any number less than 4, less than 5. Enter a number between 5 and 10. That's the validation text. Gives you an error message. The required field property. What that does, it forces the entry, forces the person to actually put in a value. So it cannot be left empty. The person cannot leave that field empty. It forces them to put in a value before they go on to the next row or record. Allow zero length. So once again, you cannot leave a cell empty. You cannot leave a field empty. So what if you don't know the value? What if you did not set a default value so that something appears? Well, the allow zero length allows you to type in double quotation mark, and that's going to represent no data. So technically it's not empty, but the system recognizes it. It is empty, but the system recognizes that you're treating it as empty, and it will allow you to move on. Because otherwise, it would not have allowed you to move on to the next row. Index, that's basically giving each record an ID so that you can easily find that record if you so need it. So those are the options you get in your field properties there. Any questions, comments so far? All right. Okay, this is the next paragraph. Are the keys. So in your database, you have 4 keys. You have the primary key, candidate key, composite key, and your foreign key. Out of the 4 keys, only 2 keys can be created. The other 2, we call them virtual keys. I call them virtual keys because you cannot create them. So only 2 you can create, and the other 2 are virtual. They're just concepts. So what are the 2? The 2 are primary key and composite key. Those are the only 2 keys that you can create. The candidate key and the foreign key are concepts. So what is the primary key? Simply, the primary key is a field that is used to identify the record. So we have a table, like for example, this customer table here. Now, we do not use the person's name. We do not use anything else other than the primary key to identify the record. Remember, a record is a row. Why do we use the primary key? Because the primary key has the characteristic of being unique. It's guaranteed of being unique if you set it up correctly. That is why we use it to identify the record. So it's kind of like how we have an ID number. We're guaranteed of that being unique. So the primary key is used to identify a record. Yes, Sajid? All right, you took down your hand? All right, yes. So the primary key is used to identify a record, as I mentioned, and the characteristic is that it is unique. Okay, that's why we use it to identify the record. Now, a composite key is simply a primary key, but it is made up of 2 or more fields. So a primary key is basically any field that you set as primary key. But a composite is basically when you use 2 or more fields to create that primary key. So a composite key is a primary key. Does that it has 2 or more fields. Now, why do we use a composite key? So in this case here, in this table, as we have this example, sometimes this CID field, which identifies each customer, might be used multiple times. And then the same PRID might also be used multiple times in the same table. So instead of creating a whole new field, maybe another field named ID, and using that, we could merge these 2 together. And the grouping of those 2 can create a whole new unique field, and we can use that as the primary key. So that's why we use composite key. Now, what is a candidate key? A candidate key is simply a field that can become a primary key. This is something optional. Not all tables have candidate keys. Like I said, it's just a concept. It's something virtual. It's just a field that can become a primary key. So like for instance, we have a table. In this table, we have a field called ID. But we also have a field called passport ID. Now we set the ID field as primary key. The passport ID, we did not set that as anything, it's just existing. But it has the capability of becoming a primary key. Why? Because everybody has a unique passport ID, just like how everyone has a unique identification number. So both could have been used, either one could have been used as a primary key. But we use ID. We did not use passport ID. So because we did not use passport ID, we consider it a candidate. Because if, for instance, like one day, we do not want to use ID as a primary key, we could simply make passport ID the primary key. So a candidate key has the possibility of becoming that primary key if we so choose. What is a foreign key? A foreign key is basically just like how we say somebody gone to foreign. They gone to another country. So a foreign key is a field that is in another table. It's in one table and it's simply in another table. So like for instance, this table here, we have the candidate key here as primary in this table here, but it's also being used in this table here. But it's not being used as primary because if you notice, it's here appearing multiple times. So this is called a foreign key. So you just got to figure out which side is the primary. If you notice a field using this, the same field in two different tables, you just got to figure out which one has the unique side. The unique side is the primary key side. And the other side, where you're going to see duplicate values, that is foreign. But it doesn't necessarily mean it has to be duplicate, because it could be unique also. Because we can talk about relationships on, and if it was like it only had like one of that entry, it's still foreign. One of the side would have been primary, the other side would have been foreign. It's just to figure out which is the main table and which is the secondary table. But that's the concept of foreign key. It's a primary key in one table, and that same primary key is being used in another table. We call that a foreign key. So those are your 4 keys. Any questions on them? All right. I'm just gonna show you quickly, just in case some of you do not do the exercise. So simply to create anything, you go to the Create tab. Under the Create tab is where you're gonna find all of your options. So simply if you select Table and you switch over to Design View, here you're gonna see the options to set your field names, set your data type, and at the bottom here is where you're going to see your field properties. How do you set a primary key? This could even be a question in the exam. How to set a primary key? You simply select the field and you select the primary key option that is under the Table Design tab. When you select that, notice the key was taken off. That's how you take off a field from being a primary key. If you select it again, it's back to being that primary key. If you want to create a field, you just go to the next row, type in the name, set the data type, and you just created a field. That's simple. All of those can be questions in your exam. How do we create a foreign key? That could even be a question. So you simply select one of the field, hold down the Control or Shift key, and you select the other fields. And then you select the primary key option. And notice you have keys appearing on the To field. How much ever other field is there can be part of it also. So if I highlight all of these here, select primary key, they're now all a part of the composite key. So those are the only two keys that you can create. Join in multiple database tables. So this is basically relationships. So tables should be joined so that you can access or coordinate information in all the fields of the connected tables. Joining tables saves you having to enter the same information into several tables. In addition, it allows you to create reports, forms, queries from the related data tables in the database. So if you do not create a relationship between the tables to show how they're connected, how the information is coordinated between them, then you cannot create queries, forms, reports, and so on from among those tables. Yes, you can create it from individual table, but you cannot create it from all of them at the same time unless they have a relationship, unless they're linked together. This means you can create smaller, more efficient tables that can be related when you need access to data. So we have two types of relationship. We have one-to-one and we have one-to-many. We also have many-to-many. Because that we don't teach that. So what is a one-to-one? A one-to-one is when this type of linking usually takes place when the primary key in one table matches the primary key in another table. So like this example here. So we have the employee ID as the primary key being linked to the employee ID field in the employee table here as a primary key. Notice the one here and the one here, that's an indication of a one-to-one relationship. Now, this here is a primary key, but this here also can be considered a foreign key because technically it's a field in this table at the top here and the same fields being used at the bottom here. So, like I said earlier, it doesn't necessarily have to be duplicates. It can be unique. It can be a primary key. So it doesn't have to not be a primary key. Yes, so that's a one-to-one there. So why is it called one-to-one? Because the employee ID is only going to be appearing one time. Remember, by default, the primary key is unique. So this ID is called one-to-one because that ID is only going to be appearing one time in that table. So 001, 001, 002, 002 is going to remain one-to-one. Now a one-to-many. This is where it's a primary key in one table links to a foreign key or a combined key in another table. So basically, once it does not link to a primary key, it's a one-to-many relationship. So as you can see here, a primary key in one table and is being linked to a foreign key or a combined key, or technically a field that is not a primary key. Because a field that is not a primary key can have duplicates of its values. So like for instance, this department ID, the department could be D01, D01, D02, and so on. And at the bottom here, that same D01 could appear multiple times. Because remember, multiple persons can be in the same department. So this has to appear multiple times. Whereas the top here, in this table, the department ID has to appear once because we're just putting information about it. So it doesn't make sense for it to be duplicated at the top here. So that's a one-to-one, that's a one-to-many. But what is a many-to-many? Well, just like how this side here is many, a many-to-many relationship is basically when it's many on one side connected to many on the other side also. So it would basically be the M to M. So like how this here is 1 to infinity or 1 to M, that's 1 to many. This would be many to many over here. Many records relating to many records. All right, not going to go through all of that. Good. So, like we said, the linking of the table shows how the information relates to each other. So, by linking this customer ID here to this customer ID at the bottom here, it shows that it's the same information. So this here is going to be a one-to-many because we can see the 1128 appearing multiple times. Same for the PRID, one-to-many because the PRID is also appearing multiple times. P3430, P3430. So linking tables ensure that the data in the database remains as accurate as possible. For example, if you wish to delete a customer who has placed orders, the database will not allow you to do so. So this is another mechanism that is useful for linking the database together. So why do we create relationships? Because as the paragraph mentioned, is to keep the database accurate. So say for instance, we enter the customer 1128 into this order table at the bottom here. Now, because we created the relationship and because I entered this customer record at the bottom here, I cannot go and delete his record at the top here. It's like if the person cannot have an order and it does not exist. So the database will not allow me to do that. So it's another mechanism to ensure that the database is accurate. Same for the PRID. I cannot go and delete small clips from this table at the top here because I would have entered it at into the order table also. So it basically protects the data from being accidentally deleted. All right, that's it for relationships. Any questions? One-to-one, one-to-many, many-to-many. All right. All right, so how do we create a relationship? Let me just show you quickly. Should have a database already. Good. So you go to the database tools tab, you select relationships, and you select add tables. A box will appear, and you simply add your table into this view here, and you simply drag and drop. You drag one field from one table to another field in another table. A line will appear. Now, in this box here, this was in your mock exam. So the question here was this enforced referential integrity? So the purpose of this enforced referential integrity is actually to create the types of relationship. If you do not enforce this here, it will not create the one-to-one and the one-to-many relationship. It's just gonna create a relationship. So let me see if I can actually delete one. Yes, good. So if I actually click on this and drag it over here, it's gonna create a relationship. Notice it's just a line, but notice there is no number. This one has a 1 because it's connected at the bottom here, but notice there's nothing at the end here. So unless you enforce referential integrity, only then it would actually create that one-to-one and one-to-many relationship. That's when it ensures that it's trying to keep the data accurate. It's trying to protect the data. That's why it's called enforced referential integrity. It's trying to keep the integrity of the data, ensure it's accurate. All right, capturing and entering data. So this is basically for. Yes, Alicia?
I think I missed something. Can you go over like what referential integrity is?
Okay, so I was saying that referential integrity is basically two things. It is what allows you to create the type of relationship. So if I uncheck it or I never checked it, notice it's just a line and it doesn't have any numbers at the end of it. This only has a 1 here because of the other relationship. If actually, I don't think it will, but actually, yeah. So notice this line here doesn't have any symbols at the end. So it's not a particular type of relationship. It is a relationship, but technically this is a many-to-many relationship. This here is many-to-many because we're not enforcing any referential integrity. So technically this is many-to-many. But until you enforce, then you're going to get one-to-one, one-to-many, and whatever the case may be. So notice if I drag this at the bottom here and create, notice it's just a line. Let me delete the one at the top. It's just a line. And if I enforce now, I'm going to get one-to-many here. So notice the one at the top there, many at the bottom there. So that's one thing that enforced referential integrity does. But other than creating the type of relationship, it's actually what links the table together and protects the data from it being accidentally deleted and so on. So as the word integrity indicates, it's ensuring the data is accurate. Clear enough?
Yes, sir.
All right. Yes, so back to the form. So you can start entering data once you have completed the table design. Now, so notice this here. When do you enter data into your table? I created this table the other day. So these aren't like actual steps, but these are like generic steps that I created as a guide to creating a database. So how do you create a database? Well, first you need to plan what is to be stored into the database, what kind of data. And then you're going to go and create that actual database file. So this is a guide to creating a Microsoft Access database. So you decide what type of data, then you go and create that database file. Then, like we said, the table is what is storing all of the data. So notice that's your next step, create your table. But after you create your table, you have to design your table. What is a part of designing your table? You have to name the table. You have to create your field names. You have to set your data type. Set the description, that's optional. Set whatever field properties you need, that's optional also. Like setting the field size and all the other properties. Then you set your primary key. Then you create your relationship. This order actually must be followed when you're creating the database. And then you go and enter your data. So notice all of this here must be completed before you actually go and enter data into a database. Because if you do before, it can actually hinder you from completing certain aspects. Like for instance, if you go and type in data into your database, it can prevent you from creating a field as a primary key. It could prevent you from creating certain relationships and so on. So that's why entering data is so far down in the database. Database is not like spreadsheet where you can just open it and start typing. You must design first and then you can enter data into a database. So all of this must be completed first, properly. Design properly, and then you can enter data into a database. So we looked at all of that. So now we can start entering data into our database. Now tables have, or forms and so on, they have what's called a design view and a datasheet view. Design view, that's straightforward. This is where you can design that table and so on. And the datasheet view is where you can view or enter that data. So if you have selected a field as a primary key, make sure that there always data in this field. So a primary key field should never be empty. To switch views between the datasheet and design view, simply click on the top left. So this might be a question. How could you switch between datasheet and design view? There's many ways you can do that. You can right click on the table. This is for any one of the objects. You can right click on them and you can go straight to design view. It won't take you to datasheet view. It takes you straight to the design view. That's one method. You could, obviously if you double click on it, it'll take you to datasheet. But if you double click, if you right click on the tab here you can switch between the two. And the bottom right hand corner also has that option. Remember why I'm showing you this here? Because during the exam, they can ask you questions along these lines. How was the different methods of doing certain things? So another method of entering data into your table is using a form. So your form is a graphical representation of your table. So where you can add data, update data, delete your records, and so on. You can give the form a different name from your table, but they still work on the same information and data. Remember I said the form is basically linked to the table. So this means that if you change data or a record in the form, it's going to be changed in the table also. A form is very good to use when you have many fields in a table. It means you can see all of the fields in one screen. If you were in datasheet view, you were to have to keep scrolling. So why do we have forms? Well, let me just give you an example. So you have this item table here, and I have this main table here, and I have this secondary. What if I needed to enter data into all three of these tables at the same time? Well, the form can be used to create the fields into one location. So you can enter data into all three tables at the same time. That's the purpose of the form. So sometimes you may need to see one record and the related data on that record in one form. For example, you may wish to see all orders for one customer. It is useful to create a form of the customer data with a subform. So that's also possible. So this is basically, note you can only get a form and a subform with two different tables. So this is information from one table called the customer table. And this is another table here called the orders table. So by pulling the fields from two different tables, you can create a form with a subform. So just remember how it looks visually. The subform part appears like this here. It's like if it's a whole different section of a form. Notice this part here at the bottom. This is the indication that you're looking at a form. And notice one is out here also. So that's why we can say it's like two different forms you're looking at. A main form and a subform. Here, we just have one form from one table. Here also. There are types of form. Let me see something. Okay. All right, field options. So data should be as simple and quick as possible. Data entry should be as simple and quick as possible. This is particularly important if a database has hundreds or thousands of records. Data also needs to be accurate. This is very important to remember. Everything we do in database is to ensure that the entry of data is accurate at all times. So to help with this, you can set the entry options for the fields. One entry option is to get data to be automatically entered into a field. For example, the quantity field could automatically enter the number 0 for each new record entered. So that's one method of ensuring your database is accurate. The field options for a form. So automatically make a value appear. In most databases, you will also need to enter the same value into a field repeatedly. For example, it's much quicker and more accurate to choose a product from a list rather than having to type it. So instead of you type in male or female, we know that for gender, those options are going to be typed in. So instead of typing, you can give what is called a value list or a combo box. Note that is what is called in Microsoft Access, a value list or a combo box, which is basically a drop-down box so that you can click on your option. So those are methods to ensure data is entered accurately. Drop-down box, checkbox. So other entry options include checkbox. Instead of typing yes or no, you can have a checkbox where a tick means yes and the absent means no. Another option is to have a radio button, also known as option buttons. These methods of data entry reduce the possibility of error when inputting data. So basically, instead of typing, you give them input options, drop-down box, which is called value list or combo box, check boxes, radio buttons, and so on. All right, so any questions so far? All right, searching and sorting. So we basically completed these two steps here, entering data, creating a form. We're now at creating queries. So that's searching and sorting there. So computers have important advantages over manual systems since they can work extremely quickly and automatically to make calculations and to retrieve and sort data into some useful form. All these functions are known as data processing. Searching. Searching a database is reasonably straightforward once you realize that you must tell the program precisely what to search for. You do this by giving clear criteria or conditions for the search. You might know what you want to find, but the software does not. So your criteria is always going to look something like this: greater than 10, less than 100. Those are your criteria. Those are your condition. And what I usually like to say, you're basically asking the database a question. So always ask it in a question format. What is greater than 10? What is less than 100? So a query, also known as a filter or a search, is used to answer a question used in the database, the data in a database. The database is searched to find all records that match the particular condition. A query is the question you ask, such as list the first names of the customers who ordered wrong tables. It is not the result. So the query is asking that question. You may make several queries to ask different specific questions. When a query is run, it produces the output. So whenever we use the query, we basically say we are running that query. So just take note of that. There's a literal run option to see the results of the query. So once you have created a query, you can run it as often as you need. So like if, for instance, you maybe added more data to the table, you could run the query again to update the query to get the new results. Even the results of the query will be updated if you add more data to the table, as I mentioned. So when you're creating a query, what questions do you ask? What data? It's basically what specific questions do I want to ask? What data am I looking for? Greater than, more than, less than? What fields do I want to appear? So even though I'm looking for quantity greater than 10, maybe I want to see the item name, because it doesn't make sense seeing what's the quantity greater than 10, but I'm not seeing for what items. And then how to sort it, alphabetical, numerical, and so on. Two types of queries we have. We have simple query and we have complex query. Those are two types. What is the difference? The simple query has one criteria and the complex query has more than one criteria, basically two or more. That's the only difference between the queries. So to search a database, you must first enter the search criteria into one or more fields of the table. Then you instruct the program to find all records that match the condition. So the word criteria in a database means you want to find only certain records and ignore others. The ones that do not meet the criteria condition, so they're going to be ignored. If you want to limit the results of your query, you can set up specific criteria. If a record meets those criteria, it is included in the results. Whenever you type in numbers, you do not need to include any formatting such as $ and percentage sign and so on. If you're searching for text, it must be in double quotation marks. And there's a show box. This was an actual question in one of the exam. Like for instance, these fields here, if you want them to be shown in the result, you have to check the box. If you leave it as unchecked, it will not show up in the results. Yeah, that's it from that paragraph. So these are the operators that you can use, straightforward. You guys know about them. Equal, more than, less than, equal to. The asterisk we call that a wildcard. It's used to represent unknown data that you might not know about. So for instance, if you type R asterisk, if you search for R asterisk, it's going to find all words that begin with the letter R. If you search for asterisk R, it's going to search for everything that ends with the letter R. And if you search for asterisk R asterisk, it's going to search for everything that has a letter R in between. So the wildcard asterisk is used to represent that unknown data. Okay, just note that if you're given a design view for a query, just know that you cannot have duplicates of the table. So if you had another table at the top here, the same thing, product, PRID, and it's basically looking like the same thing. It's not good. The query will not work. It will not run. So you got to delete the duplicate. To do that, you simply click on the table. It's going to be highlighted, and you press the delete key. So you do not have duplicate of the same table. What else? What else? What else? What else? What else? All right, so the next thing is that when it comes to the criteria, we have two types of criteria. The AND criteria and the OR criteria. So the visual difference between the two, let me pull up this spreadsheet. Query criteria. Good. So the visual difference between the two is that the AND criteria, the criteria is typed in the same row. So as you can see here in yellow, the criteria for looking for A asterisk and greater than 10 is in the same row. Whereas the OR criteria, it's in different row. So A asterisk greater than 10, they are in different row. Doesn't matter which row. Now, if it's in different row, we call that OR. Same row, we call it AND. That's the visual difference. What's the second difference? The second difference is how they answer the question. So in AND criteria, all questions must be true at the same time. All the criteria must be true at the same time. So notice the result at the bottom here. It has an A. It starts with the letter A. The item starts with the letter A. And it is also greater than 10 at the same time. So all questions have to be true at the same time for the record. Now, for the OR, at least one has to be true. Any one. And it's going to give you the record. So notice A asterisk, we got apple, we got acai, avocado, apricot. But notice we also got banana, mango, and blueberry. So because we got greater than 10, notice the banana, mango, and blueberry, they answered that question correctly. The 20, 15, and 22 answered that one. So that is why they appeared. Whereas for the AND, they did not appear. Not even the avocado, which one? The acai. The acai did not appear on the left-hand side. Why? Because the quantity is 8. It is not greater than 10. So the and, everything has to be true at the same time. The or, at least one has to be true. So that's the two difference there between the and the or criteria. Any questions or comments so far? All right, so we have what is called the reverse query. Now, if we do not want something to appear in the query, we can use the not keyword. So basically all the time we're looking for something. So like if we say we want greater than 5, we're looking for everything greater than 5. Now say for instance, we do not want to see a certain person or a certain item. We can use that not keyword. So if we want to see everybody except Lou, we type not and then his name. So everything is going to appear except his name. In this case here, if we wanted to see everything except avocado, we would type not, open double quotation mark, avocado, close quotation mark, double quotation mark, and it's going to give us everything except avocado. So that's called the reverse query. All right, sorting is straightforward. In the database, in the query, let me see if I have one. There's a literal option, the sort row, and we all know what sorting does, but just for exam purposes, they ask you how to sort a query. There's a literal row named sort. So under each field, you can select the drop-down arrow to indicate how that field is going to be sorted, ascending or descending. Yeah, and that's it for that chapter there. So just to note the view that we have right now, the interface. So the first row is the name of the field. That's straightforward. The second row is what table that field is from. So it's this ID field is from the item table. Then the third row, which is where you can sort it. We talked about this show checkbox. This is where you check to indicate that it's going to show in the result. You have the criteria row. If everything is typed in the criteria row, that's called a AND criteria. If anything goes into the OR row, we call it a OR criteria. But it has to be in both criteria and OR. So that's the interface here. If no questions, we shall move on to calculated field. Now, a calculated field is basically a new field that you create. A calculated field is also called a virtual field. It's not technically a real field because it doesn't exist in the table. It does something that you can create on the spot. So the syntax for creating a calculated field is new field name followed by a colon and then the formula, the expression, whatever you're going to be calculating. So this is an example here. The new field name is total cost, colon, followed by the field. Notice the fields are typed in squared brackets. Then we have the multiplication operator and then another field here. So the fields that you're calculating, just like if you're creating a formula, but the fields go in square brackets. You'd use your whatever operator you have to use, plus division, whatever the case may be. BODMAS also applies, but you just got to remember the syntax, the structure. New field name, colon, followed by the formula, basically. So note, there must be a colon after the new field name because that's what's going to create that indication, the separation. The field names must be in square brackets. You must type the correct field name because the system won't recognize it. That's straightforward. And the name must be meaningful, but you can use space. This one here allows you to use space because once again, it's virtual. The query also has a type of query called aggregate query. This is where you can group data together. These are some of the aggregate functions, which should be straightforward. Whereby sum, you can add everything together, get the average, the minimum, maximum, or count how many entries appeared. So it's just grouping the values together. Those are called aggregate functions. To use the aggregate function, that might be one of the questions. You basically, in the design view, you click on the totals icon. When you click on the totals icon, a new row will appear called the total row, and you simply click on that group by. A drop down will appear like how you see in here, and you select which one of the group or which one the aggregate function you want to use. So let me just show you. So you select totals at the top here, a new row will appear, and you simply click on the drop down for whichever field you want to carry out the aggregate function for. Alright, so you can also do calculation with words. Similar process with the number. New field name here, colon, the fields that you want to join together, but it's not like literal calculation, just that you can merge them together. So to merge them together, same process, put the field names into square brackets, but you use the ampersand to indicate you're joining them together. If you want space, it has to look like this here. You need to use 2 ampersand and double quotation mark, and between this here, you need to indicate how much space you want to add between those two entries. So how much ever space you put between the double quotation mark will actually appear. I think I've seen this in an exam, one of the past papers. They ask you, what is this error here? So you get this error when you do not type a field correctly. You do not type the name of the field correctly. So in this case here, they did not spell quantity correctly. So it's telling you which one of the fields. You typed QNTY and it's not finding that field name. So how do you fix that? You fix it by simply typing in the correct field. I'm not typing it here, because if you actually type it here, it actually doesn't work. You have to go to the design view and actually type in the correct name. So like for instance, if I delete the Y from QTY and I try to run, notice I got that same error here. So how do you fix it? You basically try to get into design view and type in that correct name. So we should know how to get into design view to get that correct name, type in that correct name. If you don't know, you can simply right click on the field and select design view. Because if you double click on it, it's going to give you that error. Let me just show you. So take out the Y, save, close. If I double click on it, I'm going to get the error. I won't be able to go in. If I click OK, I went in here, but then you got to switch over to design view to fix the name. So just know that you got to go into design view in order to fix it. All right, so that's the end of another chapter. Any questions, any comments? All right, reports. So a query simply selects particular records from the database. Often you may want to display only some fields from the records that are found, or display the records in a particular order. So a report is an effective way to present your data in printed format, because you can control the size, the font, font size, font style, color, appearance, and so on of the data, the headings, and so on, with the report. So that's why you use that when you're printing. Fields in the report, you can group them in certain manner, and you can even use the aggregate functions. We call them statistical functions. Sum, minimum, maximum, average, and so on. So a report will let you specify these things, which fields to display, where to display the field, in what order, how they're going to be grouped together, and then those statistical groupings, average, max, min, and so on. We have two types of reports, basically just the format of them, tabular and columnar. So tabular is basically a table. This is what it looks like. So it's basically structured like a table. Columnar looks like a form. Like, think of it like a receipt. So notice all the records are basically coming in a downward manner. It's basically two columns. All of the fields in one column, all of the entries in the other column. And this here is another record. So it's coming downward. It's in a form manner. So when a tabular report is printed, multiple records are printed on each page. So like, which one can fit the most information on a page? The tabular report. That can fit more information on a page. Each record takes up one line in a table. The name of the fields are printed at the top of the table. Options provided in the report will let you determine in what order the names are printed on the report. Grouping could be used to divide the field names on the report into groups. For example, the types of items could be grouped by the supplier. Most tables will print each group on a separate page. Now the columnar is going to print each record on a separate form. Usually each form is printed on a different page. Columnar reports are often used for printed items such as tickets. So the columnar is mostly when you want to like section off the information and print it off on like a individual page. Whereas the tabular is going to group everything together, trying to take up as much space as it can. Well, the rest is basically how to create a report. This box here is shown every time you are going to create a query, form, report, whatever you're going to be creating, except table. Whenever you're creating a query, form, report, they always show you this at the top of it. So basically, you can create a query, a form, and a report from a table or a query. Just take note of that. That's why that shows up there. This view here is where you can sort or group. This is where you can group your data. So if they ask you, maybe they show you an image of this here, ask you what is happening here, it's basically being grouped by last and first name, because you can see it by the indication that it's this box here coming outward here, and this is basically falling underneath it. So it's indications being grouped by first and last name. Here, in this view here, you're setting the sorting. So you're picking the field and indicate how it's going to be sorted, ascending, descending, and so on. And this option here is where you select whether you want to do sum, average, min, max, and so on. So after you select that option, this is where this box will appear. So you check, you're going to see the fields that are available for the summary option, and you simply check which one you want to have, min, max, and so on. You give it a name, and you're basically finished. So remember, this here is tabular, because if we draw lines like this here, we get a table. Tabular is table. This is also tabular, as we can see a literal table. This here is also tabular, as we can see an actual table. Tabular, remember table, you see in the headings are in the first row. They're nowhere else. To print the report, you can just save it as PDF, export as PDF, or save as PDF. Let me see something. Save as, yeah, save as, and you can choose where you want to save it as PDF, and you can be able to print it. So just in case they ask you any question on printing. So you can save it as, you can also export it as Excel file, PDF file, rich text, HTML, and so on. All right, importing and linking. So you can import data from another database or from another application into an existing database. For example, schools could each send a database file to the National Sports Association for the upcoming sports meet. This data can then be imported into the association database so that the categories of sports and age groups can be organized without having to re-enter the data. So basically, you can merge or combine databases using this import option. So this is why we actually name our databases without space, because when you do an import, it treats the space as two different words, or how much ever words you would have typed. So this is one reason why we use no space, or we use underscore, hyphen, dashes, and so on. Whenever you export in, we use a small test amount. So take note of that. You would try the first 10 records and the last 10 records to ensure that it was imported and exported correctly. So you don't transfer the entire table. You test with small amounts first. That could be a question. All right, so exporting, even copying is also considered exporting. So like for instance, how I have this table here, or this query, I could select the top left hand corner here to highlight everything, and I could right click on it, copy, go to a spreadsheet, and paste. That's also called exporting. So exporting is simply transferring the data to something else. So copying is also exporting. Developing database applications. So before you create your database, you need to think about the most efficient and convenient way to store information so that it can be retrieved in the format you want. Although database can be modified after it has been created, it is much easier to get it right to begin with. Points to consider are: name your database, tables, forms, queries, and reports. Like any other name, they should reflect the information they contain. So it must be meaningful. The way in which to store the information. For example, names of people should have at least 3 fields. So you should break up a person's name, address, and so on. So title, initial, last name, to give maximum flexibility. Similarly for address, you can break it up into fields, building, house number, lot number, street, town, country, postcode, and so on. So it's appropriate to separate data into different fields. The number of tables and fields you require and how the tables might be linked. Try to think of all the information you might want to get out of the database. The name of the fields, they may be up to 64 characters in length, but about 15 is more normal size. So you try not to have your field length, or sorry, the field name to be too large. You can use letters and numbers, but avoid space and symbols. Use underscore to separate names and sensible names. Size of the field, you might choose to use a field size of 8 for text field. That might store 8 character code. That means you cannot accidentally type more than 8 characters into the field. Type of data to be entered. You might need to be aware of specific numbers that will not be allowed to use in calculation, as opposed to numbers that will be used in calculations, date and currency. This can help you to decide what data or fields to use for each field. We basically considered this already, setting various data types. The design of forms. If the information is being taken from, for example, a paper form, it is more efficient to design your online form so that information is basically entered in the same order as that physical form. When you have set up the structure of your database, put some information into the database so that it can be tested. So you're finished designing the database. You don't just go and put all of the data into the database. Once again, you use a small amount of data to test that database. Then you run some queries, you run some reports to test the database to see if everything is working. And then you put all of your data into it if everything is working as it should. Common design problems. There are 7 common pitfalls to keep in mind as you design your database. These problems can cause your data to be harder to use, maintain, and retrieve. The following are signs. You have one table with a large number of fields that do not all relate to the same subject. For example, one table might contain fields with information about your customer as well as fields that contain sales information. Each table shall contain data only about one subject. So that might be one error there. A table that has a whole set of data inside of it, that is wrong. It should only be about one subject. You have fields that are intentionally left blank in many records because they are not applicable to those records. This usually means that the fields belong to another table. So if a field is constantly being left empty, it could mean that it shouldn't be in that table. You have a large number of tables, many of which contain the same fields. For example, you have separate tables for January sales, February sales, and for local customers and remote customers, in which you can store the same type of information. Try consolidating all the information about a single subject into one table. You may also need to add extra field, for example, to identify the sales date. So yes, you're going to separate the tables for different subjects, but you don't want to separate them so small that you create too many tables. So we don't need a table just for January, just for February. We could store it into one large, maybe like a yearly table instead. Yeah, and that is it for database. Any questions? All right, I think we can wrap up here for tonight. Tomorrow, if we're available, we can work on another topic. Any questions before we close?
No, sir.
All right.